Everyone can see?
Yes, sir.
Okay, so this is the Etap 19 version, which you can see he is opening right now. Okay, now click on the file menu. Etap is a software which is used for the system study purpose. So basically in it, we can prepare SLD, and based on that, we can make our system stable based on some various conditions. So yes, click on the new project. Yes, provide any name. Okay, yes, provide any name. Okay, no. We will use the metric system. So at the left side, just click on metric. Frequency is 50 hertz. So we will use this system, right? Okay, click on OK. You can write your name.
Yes, sir.
Yes, you can touch. Click on OK. Has even anyone seen the this home screen of Etap?
Yes, sir. I can see.
No. Apart from see before this as well, has anyone seen this home screen?
No, sir.
No, sir.
Okay, so click on maximize button. So this is the home screen. Okay, at the right side, you can see various legends are mentioned. So just click on the cursor on the legends. You will see that the name will appear. Okay, so all the
Yes.
electrical legends are mentioned here. Just come below. See the slowly. Composite motor, cable, transformer, everything is there. Okay, so just show it from the top. खाली है अभी नहीं खा रहा okay. So this is the basic the legend which I want to show to everyone. With the help of these legends, we can make SLD. So I am just assuming one condition for the SLD, that I am getting a 66 supply from the grid. After that, there is some transformer which is providing the cable to the 6.6 kV motor feeder. And after this, there is a LV distribution which is feeding the LV motor. So like this, we will prepare the SLD. Okay. So click on the grid button, grid legend. There is a power grid legend. Just click on this and just take it thoda upar, slightly above or upar. Yes, leave it here. After that, insert cable. Don't create too much gap. Okay, after this, select the breaker, high voltage circuit breaker. After this, there is a transformer. You just click on the transformer and select it.
Two winding.
Yes, two winding. Yes. Yes, after this, there is a cable. Yes, after this, there is a high voltage circuit breaker. Then after this, just select the bus bar. Bus, upper. Yes, this one. Yes, slightly below. Create some gap. Okay, now if you take your cursor at the right or left side, you can see that one double side arrow will come. So just take your cursor left or right. So just stretch the bus. No, when the double side arrow will come, then you have to stretch. Leave it. Yes, now double side. Yes, now stretch at the right as well as left side. Basically, it's a bus, right? So which is used for the making the feeders. Slightly थोड़ा और बढ़ाओ उसको both left और right side. Yes, after this, select the high voltage circuit breaker, then cable, then motor, and then insert this left side, not from the center, start from the corner. Cable, and then motor, induction motor. Basically, rule, okay, I will tell you later. Like this, create 5 to 6 motor load. Create some gap in between cable and motor, okay, so that this looks good. No, don't create this much gap. It's a very huge gap. We have to create more loads, right? Just take it slightly left and don't create this much gap. I hope everyone can draw SLD like this, right? And they have done it as well, right? At least in AutoCAD, everyone has drawn a SLD, right?
MATLAB, I made circuits.
Just create some loads like this. Don't do anything apart from this. See, you can select the motor, cable, and breaker. Then you can provide Control C plus Control V also. You can do.
Can I select this whole
And
and
yes. This whole.
shift the
Just select from the base, from the left side bottom, and then select. Right click and then select. No, not right. No. You have not selected the cable. Just delete this. Delete this. Press the delete button.
breaker, cable, circuit breaker.
Select the from the basically you have to click the left button on the mouse and then select. The rectangle will come, then you can select. No, first click the yes. No, left. Yes, like this select. Yes, Control C plus Control V. Okay, it's enough. Various motors have been created. Now, after this, slightly stretch at the left side, right side. Just stretch it. We will add one transformer, a high voltage circuit breaker, and then cable, and then transformer.
That is enough. See?
Yes, it's enough.
High voltage circuit breaker,
Yeah, high voltage circuit breaker, then cable. Then
transformer.
transform. Now create, select the bus duct and then low voltage circuit breaker.
And what? Low voltage circuit breaker.
Yes. No, first select the bus duct. Basically, up to 1 MVA, we are using the cable, and after this, bus duct. It's not a rule; it's a general practice.
Bus, bus. Where it will go, sir?
No. Secondary side of the transformer.
No, no. This one.
After this, high low voltage circuit breaker, and then bus.
What is the reason behind the bus duct, sir?
See, basically, suppose you are taking the cable. In that cable, for the secondary side of the transformer, more number of runs will come, right? Means the cable runs will be higher. So it is difficult to terminate those high number of runs. So what we are doing, basically, we will go for the bus duct and we will tell the switchgear vendor as well as the transformer vendor to make the flange like this. So the termination will be very easy. That's why it is used. Okay, because you can see that if you size the cable, number of runs will come very high. So difficult to terminate. See, it's not a we can go for the cable as well, but as a general practice for the time for the sake of termination, we are using this.
Why we don't use here the bus duct?
You can use the busted here as well. I'm just showing the. You
Okay.
can use the busted as well.
Okay.
It's not a problem. But currently, just I have shown you one transformer. I have modeled cable and one transformer busted, so that we will sing something more. Yes, like stretch at the left side. Yes. Now select the low voltage circuit breaker, or you can select the fuse as well. Okay, select low voltage circuit breaker, then contactor, then cable, then motor. So like this, add few loads.
So,
Any question anyone wants to ask in this SLD? Hello?
No question, but sir, I don't have a software.
Why you are not having software? I told you to talk to Vijay.
I sent email and also WhatsApp, but he asked me in evening he will send.
Basically,
But
no, no. Basically, he
uh,
has provided the link, and based on that, you can download. The link is there. What is the problem?
can you send me now link? I will.
So link is there. I'm not sending anywhere anything. Just go in the advanced chat box. I have told him to share the link, and he has shared. Right?
with Etap, he will send with you will you have to share the your screen to him. Then he will help you download
No,
any
I,
test.
Okay.
no issue, but that I don't have a link. Basically.
No, no. Yeah. Shivam, just show him link in the advanced option. Advanced.
I messaged him on WhatsApp.
No,
Then
no.
he
He
Sir,
has
no,
already shared. No, no. He has already shared. Why he will reply again and again?
No, sir, I don't think he shared in the group.
I have mail.
But then how, Shivam, you have got this?
Sir, I asked him. I want the dialects and ETAP software. Then he asked for my name and email ID. Then he emailed me the downloading link of ETAP and dialect software. Then I downloaded them.
So you have not got the link?
No.
I have
I am not
Okay,
got.
okay. Then I am sending him message right now.
Okay.
No one has got.
No, sir.
Okay, I messaged him. He will do.
Okay.
Okay. Anyway, after this model cable and then motor.
cable contact and then cable.
Yes.
So same configuration of same
Yes. Yes.
combination of load.
Yes. Yes. Now create one more. Okay. After this, just add some power feeder. Motor feeders are enough. Now select the breaker and then lump load. I will tell you what is lump load then. Yes, like this, add two loads.
Breaker then lump load.
Hmm?
Breaker after the lump load.
Just 1 minute, let me share something. Okay, I had shared one Excel file over Teams, or sorry, over Zoom. Just download that as well. Okay, are you downloading? It is in the Teams. So not Teams, the Zoom. Yeah, transformer sign you downloaded. Just copy and paste it somewhere where you want to put this as a record. Just paste it somewhere. Okay, leave it, just minimize. It is not required right now. I'm just telling, just download and save it wherever you want to do. Okay, now after this breaker, select the lump load. Lump load is basically the combination of motor load as well as the power load. Just click, first select. See, there are two types of load. One is the static load and one is the rotating load below the motor. Okay. So just select this lump load. Suppose a load up to 100 kilowatt. Suppose in my plant, there are various load which are very small kilowatt rating, right? So what we are doing, we are just adding all the kilowatt for the motor as well as power, and then creating them as a lump load. Suppose in my plant, 50 are the motors of 1 kilowatt and 50 are the power feeders. So I will use a lump load, out of which 50% will be rotating and 50% will be static. Okay, add one more lump load. I will tell you how. Create some gap in between the breaker and the lump load so that the value you can see easily. Okay, like this, add one more load.
There will be cable or not within the breaker and the lump load?
Yeah, it is it is basically the combination of all the loads, right? So it is not recommended to use cable because various loads are there. So
Okay.
even if you size the cable, that will not be perfect, right? Because it's a combination of various loads. Either you size for the different of individual loads, or you cannot, but you cannot combine because load location could be different and the voltage drop problem we cannot satisfy, right?
Okay, sir.
So it is not recommended to model cable for the lump load. Yes, create some gap with this. Okay. Now click on the double click on the lump load. Double click. See, in the nameplate, just click on the nameplate. Nameplate. In this, you can see 80% is constant. The 80% is the motor load, 20% is the static, right? Top is written means if it is suppose this load is 100 kilowatt, then 80 kilowatt will be motor and 20% will be the power. So this we can change. Basically, there is a scroller is there, slider is there. So based on that, you can slide it and change the change it. Okay, currently it is 80, so you can basically change the rating. So just take it left or right. Okay, so like this we can change, but we should keep it as by default we should keep it like this because it's a worst condition. So we should go with this only. Okay. There are two types of load. One is the motor, which is the rotating in the nature, and second one the static, which is not rotating, like electrical heater, which is not rotating, like lighting, which is not rotating. So for this, we assume the static load, and for the motor, which is running.
20% is our static load, which is not
Yes,
rotating.
yes. You can see the at the top it is written. So mean 20 kilowatt is the static, means the lighting, heater, this could be the load. Okay. So
And the motor, the induction motor, which we have separately added in the
see load up to 100 kilowatt, we should model like this. If your load is 1 minute, the call is coming from the advance, just one minute. Hello. So I have just now talked to Advan. He has told me that he has already provided to many of you, Imran. He will share you the link once more. Okay, so you will get it as well. Apart from you,
Okay, sir.
many has got it.
Okay, sir. I will check my email.
Okay. Now the concept is clear. We should model like this. See, if you are having any confusion in any load, you should consider that load as a static load. Means if you are confused that whether it is static or or the rotating, consider it as a rotating because it's the worst condition. So for the Etap we can use like that.
So the motors, induction motor which we have used here and here,
1 minute,
these
call
are
is coming. 1 minute, call is coming. Yes, tell me.
the induction motor which we have used here and here as a load.
Huh.
These are dynamic loads, and these are
Yes,
not
yes,
static
yes. Rotating load.
rotating load. But the lumped load which we have used, only 80% of that has rotating load and
No,
20%
no.
static.
See, so we have modeled all the rotating load, but after this as well, some motor will be left, right? Means the 10 kilowatt small size motor will be left. So for that, we are not modeling them individually. We are considering we will basically add all the small kilowatt rating and then consider it as a lump load. Okay, what we will do, either we can model all individual small motor as well, right? Or either we can use the lump load. So this is
Okay.
what we are doing. Rather than modeling individual small kilowatt motor, we are just combining on the kilowatt and then model them as a lump load.
Okay.
Okay. Okay. Apart now, I should tell you how to save this file. Remember this Etap file. Just close this. Close this. Now I will tell you how to save the file. Press Shift Control plus S. This is the save as option. Okay. So Shift Control plus S. From
Yes.
the keyboard, just press Shift Control plus S. And at the desktop, create one folder. At the desktop, create one folder, and then save it. Save all the files inside this folder. You will see many files will come. Yes. Now go to that folder first. Yes. Save. Now go to that folder, then you will see many files are coming. So first I will tell you, no, just cancel now. Just minimize this. You have opened it again. Anyway, just cancel this. Anyway, go into that folder. So you can see various files are coming. The main file is the OTI file, .oti file. This is the main file. Rest all are the backup file. Remember, you have to share all the files by compressing them. Otherwise, no one can open, okay? Because all are the backup file. So that is required, but main file is the OTI file. Anyway, just open the OTI file and then come back. Come back to the SLD. No, you cannot open from here. You have to open. This is already opened. Basically, you have to click on the file menu, then browse. Then only you can open. Okay. Oh, open project. Open project. Now,
This one.
just okay. Open. Yes. Yes. Anyway, so this file is created. Now we have prepared the SLD. Okay. Now we have to basically first to check the continuity, whether all the loads are connected or not. So in the second row horizontal, there is a continuity check option is coming. Below the file menu, horizontal, top horizontal, second row. Below the file. So in this one continuity check option is there. Below. Just come right. You will see the continuity check option. Yes. Yes, this one. So just click on that. Yes, click on this. Click on this. Click on this. Click on the check circuit continuity. Okay, means okay. Just what you do. Don't connect the uh, uh, don't connect the CB1 with that bus. Just create some disconnection. Yes. After this, just delete it.
This one.
Yes. Just delete it. Now click on the circuit continuity. You will see whatever is not connected. It will be basically it will not be highlighted, right? So based on that, we can find out where our circuit is breaking. So this is to be done after because no current will flow, right? The circuit is break, no current will flow. So now we have checked the continuity. Now connect this cable with the breaker. Yes. Okay, now continuity is there, right? So we have already shared. Now we will provide some rating. So first click on the grid. We are only providing the rating, nothing more. Click on the rating. Right here, 66 kV. Okay. Click OK. Now click on the transformer. You will see that now click on the transformer, nothing more. Rating. You can see the primary is already converted to 66. Now in the secondary, just write 6.6. Okay, we are not sizing any transformer right now. So click on OK. Now the bus is converted to 6.6, right? Now we will provide the rating to the motor. See, the standard for the motor is up to 160 kilowatt. We are taking it as a LV. If our motor is dual control, if our motor is VFD control, we can go up to 315, means 315 kilowatt also we can model it as a LV. What is the reason? Because in case of VFD, the starting current will not be there. So basically there will not be drop. So that's why we are using that. So more than 160 kilowatt, we will provide it in the ST. Now come below.
We can do.
No, we are not doing anything. Just providing the rating only. Just click on OK. No, don't do anything. We will size it. Click cancel now.
It is not visible. Sir.
Just press enter, then it will be it will go. Now click on the motor. We will provide the rating to the motor. Yes, nameplate. Click on okay. So it is already in the kilowatt. If you click on the kilowatt, so it will convert to HP. Just click on the kilowatt. Left to the kV. So it is now HP. Now once again click. It is kilowatt. So provide rating like 1000 kilowatt. Suppose this is a 1000 kilowatt motor. So right here 1000 kilowatt. Click OK like this and click all the motors and provide the rating. Make it 800. So more than 160. Yes, right like that. Uh, 1500. 2000, 2500, 1200. Like this, provide rating. Whatever you want. Three 3500. See, I have used the motor up to 5 megawatt on 6.6 kV. But general rule is for 4 megawatt and never we should take it in the LV. So up to 160 we can take it LV. After this 6.6 kV and after this 11 kV. This is a general rule. It's not a standard. Okay. No, 3800 there is no motor is available in the market. 3500 you have given.
Yes, sir.
Okay, then provide 500 kilowatt is also available in the market. How many motors left? Okay, so 2 megawatt you can provide 2000. Okay, now just click on the transformer. You will see the primary is already converted to 6.6.
Yes, sir.
Right, so provide the rating to the secondary 0.415 because it is in kV. So instead of 415, we will write 0.415.
These are now LV motors, sir. LV
Yes.
side motors.
So, yes, sir. So just click on the motor and provide the rating. Up to 160 you can write here. One 160, 110, like this. One 75, 50, like this.
Why this is coming, sir?
One
Typical
to
name.
see, it is the basic the library. The Etap is there having the data as per NEC and as per manufacturer. So you can select any data. NEC is the as per standard what will be the current rating and as per the manufacturer data. So this is just written here. Click on OK. We are not doing anything apart from this.
When I'm entering the rating, it is showing up here.
It is
It is coming. The pop-up is coming.
yeah. That's why see in the pop-up you can see first is the NEC and second is the manufacturer. So this is the data which the ETAB is having. So we can select anyone.
So why this was not coming in the HV side motor, sir?
Because that is because the Etap is having only one data. Here the Etap is having two type of data. One is NEC and one is manufacturer. But in the HV, Etap is only having the one type of data. That's why it is not coming.
Motors are covered, sir.
Just click on the lump load. So you can provide the rating like 100 kilowatt you can provide. Click on the MVA, so it will be converted to KVA, the MVA like that. Click on the MVA, then again click to KVA. So provide 1000 KVA. No, not 1000, 100. And second one you can provide 125.
Kilowatts, sir. ये तो अपने आप Yes, sir.
So we have provided rating for everything, right? So you can see here various cables are there, right? So I am just giving you one exercise. You have to size one LV cable and one ST cable, and that data we will put in the ETAP. Remember, ETAP provides error only when your cable is undersized. Okay, we can also size the cable with the help of ETAP, but right now I want that you do it manually. When we will go further, I will tell you how to model this. Okay, so are you able to do that part? Means one HT and one LV. So you can select any motor and size the cable. I am giving you the fault table. If you are able to do, it's good. Otherwise, we will do. So can you do?
So we'll try, sir.
I think you can do, right? It's only one cable which we can do, right?
Sir, LV cable. This is the LV cable, sir. LV side of cable.
No, the prime second is bus duct. It's not a cable. It's a bus duct.
This is you have to size this one and this one, sir.
It's up to you. I'm not compelling you to size any cable. So, okay, based on this, we will size the transformer. Okay, so what you can do, just open the Excel. First, we will size the transformer. So in this SLD, you can see that my ST transformer is tapping both the LV as well as the ST load, right? So first we will size the LV transformer. So just note down all the kilowatt rating in the LV transformer sizing. So just provide the rating. Just copy and paste the rating here.
So all the KV side.
First LV side, then we move to the ST side.
I have to copy all
No,
these.
you cannot copy. Basically, you have to write the rating here only. So first is the ST cable, then just write down the rating based on the SLD.
First this transformer, sir.
Hmm?
First this transformer, sir.
LV transformer. Like LV transformer, you can see various loads are connected, right?
Confused होता है अभी क्या करना है सर what I have to do sir
You can see the various motor slots are there, right? For the LV, low voltage, 415 volt, in the secondary side of the low voltage transformer. Okay, anyway, we will do it later. First, you have to size one LT cable and one LT cable, right?
yes sir
Do you understand till now what we have done right now? Till now, we have just prepared one SLD, and then we have we will do the system study based on that. Right?
Okay, okay, sir. Understand.
Just one SLD we have done.
and now we have to size the LV and HV side cable
One ST and one LB, so that see, we have done the cable sizing just 2 weeks before. So I hope you have not forgot, right?
yes sir
So that's why I'm telling like this. Okay, just do this and then come back to me. Okay, we will not go too fast because we will finish an earlier. Till now, the things is clear.
yes sir
Or
yes,
if
sir.
anyone wants to add any other type of node, we can do that as well. Anyway, this is enough now. So we will make this system stable. So we will do the transformer sizing, capacitor sizing, cable sizing, voltage drop calculation. Many things will come in this, right?
okay sir
Okay, so just share this. Okay, no need to share now, or you can basically you have to compress the folder and then share it over Zoom so that rest all also can see this. Okay, from tomorrow, just have this Etap.
I have to compress all these 4 files
No, where is the folder? Basically, you have to compress the Etap program folder. You cannot. You can see various files have been made, right? You have to
yes sir
compress the Etap program folder in which all the files are saved.
it will not compress if the program is in the load position sir
Yeah.
if it will not going to compress if the program is running currently sir
No, you cannot do this. You have to basically close file, then only because your changes will not be saved otherwise.
control save my process
Okay, so just compress it and save it over Zoom so the rest all can see.
this is the Etap program folder na sir
Yes, you have to basically right click and then compress. Okay, now you have to share it.